Okay, so we're going to talk about schema design. So one thing that's sort of to think about is that when we looked at the movie database, that schema already existed, right? We could let's sort of take a step back and think about, well, what if we did have this data? How would we end up structuring the data? And again, when you build your own applications, you're going to have to make decisions about how the data is going to be structured. You don't have it; it's not set in concrete. But you want to think that stuff out, because that's one of those things where changing it can sometimes be a headache when you end up changing your data structure. It happens, but it shouldn't happen needlessly. Okay? So when we talk about the design of our database, the relation schema, we could talk about how our table is defined, the schema of our table, and then we can look at what the schema of our database is overall. When we end up looking at our table structure, we've seen that we're dealing with our columns, which will tell us what the attributes are. When we think about rows of a table, we can think about them as being instances. And our database management system is managing this whole process. So when we end up looking at data modeling, the thing to do is to think about, we are modeling some real-world relationship. So what is that thing that we're modeling? So we want to do it in a way that makes sense, right? We want to name things that end up making sense. We want to make them somewhat flexible for changes. And the other thing is that we also want to make it in a way, so we're structuring it in a way that it's not overly complicated, because the more complicated our database is, and if we're adding tables unnecessarily, to some degree, the slower it is. But again, I wouldn't necessarily think about, hey, look, I got to get all this stuff in one table, so it's incredibly speedy. This is not the time for that sort of thing. So there are a couple of different ways of sort of designing an application. Right. First of all, one way of doing it is if you're building an application, a way to start is to say, what's this application going to do? Right. If you decide, hey, look, I want to have this application that's going to, display a list of widgets. Right. So, all right, well, here's my page. Here's a list of widgets. Well, right off the bat, it's going to jump out at you. I'm probably going to have some table in my application called widget. Right. If it turns out that a widget has an owner, okay, you're going to think about, well, I'm probably going to have some sort of entity in my application, some sort of table in my application. Now, I'll use these terms interchangeably, entity and table, some sort of owner within my application. So there's a couple of different levels of design. And the one from conceptual to logical, conceptual is more of just sort of thinking about things a little bit broadly. When we think about logical, we're thinking about what the actual attributes of our table are going to be, what those joins are going to look like. When we think about physical, we're thinking about the tables themselves and what our statements are going to be, our create statements in order to create the table. So this is when you start thinking about conceptual, think about sort of drawing on a napkin. When you think about logical, maybe some more detailed drawings on the napkin, and physical, you're actually getting in there and actually creating the tables in your database. So here's an example that we're looking at. Let's say that we wanted a program that we're going to journal in, and we wanted to be able to enter text of each entry, and we wanted to see these entries chronologically. Well, from the perspective of a conceptual design, and again, this is just, what's the word for it? Convention. You have these entities that are in boxes, and the only things that we would need for every data entry would be the date, right? Because again, if we didn't really care about the date of these things, then we wouldn't need the date, but for sure, we want to have some text that describes our entry, right? This would be sort of a simplistic conceptual design. When we end up moving over to the logical design, we're going to have some way of dealing with this data. So we're going to want to have some ID, which is going to be your primary key. And by default, by convention, unless there's some overriding reason, you end up just calling this ID. Very often these are auto-incremented, but not all the time. Sometimes there's other ways that you can end up creating these things. We end up having a date created. Again, a lot of databases, you have the underscore case for naming things. And here we're calling our entry text. Could call it something else if you wanted to as well. Theoretically, you could call it entry, you could call it body, whatever you wanted to call it. And that's it, right? We're all done, right? Well, not exactly. So let's talk about a couple of things that we might want to do, right? We might want to have multiple journals, and we also might want to be able to tag entries and maybe find all of the entries with a certain tag. So now we're going to do a little bit more work with this, and we sort of think about how this would end up getting set up conceptually. We have a journal. We would want to have our journal would have a title, and a journal would have many entries. And when we say a journal is going to have many entries, it could have 0, it could have 1, it could have 100, right? So when we talk about that, we're talking about cardinality, okay? A journal has many entries. If we go the other way around, we would say that an entry belongs to a journal, okay? Again, it's that parent-child relationship. A journal has many children, has many journal entries. A journal entry belongs to its parent. It belongs to the journal. And again, we sort of have broken this down also to our entry having a date and having a body text. And again, just conceptually how we draw this, we could say that a journal has many tags, okay? And a tag can belong, a journal entry can have many tags, and a tag can belong to many journal entries. So when we see this many to many, more often than not, when we design it, we're going to end up thinking about having some sort of join table to design it. Think about the concept of a genre in the movie database, right? A movie can have many genres, and a genre can have many movies, right? Where we have this many-to-many relationship. Again, the idea here is to say, hey, look, for the tag sad, I want to find all the entries, okay? And I also want to be able to have an entry and give it multiple tags. So an entry can be exciting, best day of my life, right? Different tags that you could end up having for this. So here's an example, not necessarily a great example of how this would be set up, but this conceivably could be the case, right? You could have this entry where you've got these entries and you want to basically associate an entry with a journal, and we're doing it in a very bad way here. We're just having an attribute called journal title. So the journal title might be anything. Could be, I don't know, my summer, whatever, summer vacation, right? And so every time you put an entry related to that journal, you're going to have to remember to use that string summer vacation. And this is the problem with this, is that if you decided to go that route and you decided, hey, look, I want to change the title of my journal, you'd have a problem. You'd have to change it for every single entry, right? So this would be a bad design. It would be also what we would call denormalized data. When you end up seeing data that's being repeated all the time, you should look at it and say, well, that's kind of problematic, because what if I end up changing that data? It doesn't really make sense. And so what ends up coming from this is that it probably makes sense to do this. And by the way, this is, I wouldn't necessarily name things this way. I think I would, that's actually not true. I would name them, yeah, the table names usually are going to be pluralized, so I take that back. So we've got these journals and we've got these entries. What I would do differently is that I wouldn't call this attribute, and this might just be a typo, I wouldn't call this attribute journal. I would call this attribute, again, it's not a journal, it's an ID. I would call this attribute journal ID. Whether you do journal underscore ID, whether you do journal uppercase I and D, okay? And we'll find out that when we end up using some ORMs, it's going to have its opinion about how it's going to end up naming these things based upon what our relations are. If you don't know what an ORM is, that's fine. If you do, that's good, but we will be getting to them at some point. Okay, and what the ORMs are going to buy you is that you're going to be writing a lot less SQL, but there's going to be a lot of SQL that's going to be used. You're just not going to write it. So you can see here that this is a little bit of a better design where we now have the ability to modify our title and very, very easily find all of our entries for a given journal because, again, if we have the journal, we have the ID of the journal, and then we can just do a where clause and find all the entries for that ID. So how do tags fit into this? So again, we want to have tags that we want to use in multiple entries. So here, when that happens, we end up having a many-to-many table. And again, I think that this is a little bit of a typo too. This is probably going to be called entries tags, right? And again, it's when you end up seeing two foreign keys in a table, okay, there's a good shot that this is going to be some sort of join table. You could also look at the name of the table. That'll give you an indication what things are as well. Again, you want to play detective, okay? You want to look around. You want to be able to look at that database and say, I have a feeling what's going on here.
Do you have to have an ID? Can you just use like the entry ID and the tag ID, the pair as like your key, your primary key?
Oh, do you have to have this primary key here?
Yeah. And
I would.
Even though those
you don't have to. This would probably be the primary key. I would. It's just easier to manage. Okay. Yeah, I would. And most of the ORMs that we use are going to do it for you anyway, so you don't even have to worry about it. So this is going to be, again, this really is, if you understand these relationships, everything is just a variation of this. Okay? I mean, we could maybe make the case of things getting a little bit more complicated, and this would be totally fine too. By the way, you're talking about Slack. You were talking about having threads. Well, I mean, let's just say that we wanted to have entries within other entries. So maybe we would have another field called parent ID here, which would end up pointing to another entry in this table. But other than that, this is the relationships. Okay? Belongs to, has many, many to many. That's it. Okay? And the way that this would end up reading is that an entry has many tags through the entry tags table. Tags has many entries through the entry tags table. Okay? So again, belongs to many and belongs to has many. You understand those relationships, you're going to be in good shape when you end up looking at databases. So when we talk about normalized databases, what this whole slide is basically realizing that the more you end up normalizing data. What's an example of normalizing data? Well, if you take that example of the entry where you had the journal name in it, okay, and it's repeating, this is what would be called denormalized data. Okay. Now, sometimes, again, what's good about that? Well, less joins. Okay. Normalized data is going to make your database more consistent. It's also going to have more tables, so it can end up being a little bit slower. There's always a trade-off. Okay. For the most part, what I would say is you're going to shoot for normalized data. Okay. We're not necessarily worried about speed. We don't have, when we end up dealing with millions and millions of records, we could say to ourselves, hey, look, I really don't want to do that join every time. Let me go and put an entry in this other table, and it's going to be a little bit of an extra data, but one less join that I have to do. Again, somewhere down the line, you might end up looking at that. Right now, in this stage of the development, right, we're going to set things up so that our databases, we don't have repeating data. Again, think about that journal entry. Again, and it's purely just a trade-off. So denormalized data is, again, when you're sort of duplicating data. And again, the reason you might end up doing this, I mean, maybe we take the case of, hey, look, it's so slow to join with that journal table. So I gotta put that journal name in my entries table. And look, maybe it's so incredibly important, speed is so important, you would end up doing that, but you never start out that way. You can always start out with normalized data, and if it turns out there are speed issues that you're dealing with, then you could end up worrying about denormalizing the data. Again, it depends on the situations. I would focus on good, clean design, not repeating your data. Also, the idea of a database administrator. Full stack developers, there really aren't database administrators. You don't really have that anymore. When you're doing, I mean, depending on how big your team is. But if you're working in a small place, you're going to be the one that's going to be doing the database design. Again, there's going to be a database, and someone's going to say, hey, look, here's functionality that you need to add, and you'll say, oh, is there a place in the database for this, right? No, you're going to have to add that. This is a new entry, right? Or, there's several things that you're going to have to add. And again, you'll think about what the design is. Or if it's brand new, you'll think about the design right from the beginning. So it's definitely something that you have to look at. Again, sometimes databases can be incredibly complex depending upon what they're used for and what the speed is and how much data that's there. This is a great position to be in because if you are using a lot of data, you've got a big application with a lot of users, so then maybe at that point you go find yourself a real database expert to help tune things. But for the most part, this is not something you have to worry about at the beginning. So this workshop, I ended up opening it up. You're going to think about one of these applications that you use a lot and draw out what you think is going to be a sort of logical data structure for it. So, I mean, if you ended up looking at, think about what the entities are. I mean, if you're looking at Twitter, you're sort of thinking along the lines of users and tweets and following users, and that sort of thing. If you're looking at your, Gmail, right, you're thinking about, you have these, email entities, you have these, contacts, you have statuses of your emails that you're deleting or things along those lines. But again, any of these applications, again, you're not going to do a full data structure for this because these are complicated applications. These are complicated data structures. Start with something really simplistic. Think about, Gmail. What do you have? You have all these emails. Well, what's in an email that someone's displaying this information to you, right? You have who it was sent from, right? Who it's to. Okay, so so you sort of build these things out a little bit. Again, these are the kind of things where you can sort of jot it down on a napkin if you want to. Again, this is a fairly quick workshop. The idea is, you're going to draw these things out. We'll put them up on a board. We'll end up, talking about them. Again, you don't have to think that you're actually building this because you're not, but just an idea of how these things might end up being structured. And this is a quick one. This doesn't, I think, go past Tuesday. All right, so let me stop recording this.